Good morning, students. So this one is our sixth lecture of information theory and coding. In the fifth lecture, the earlier lecture, we have discussed something regarding zero memory source, and we defined if the symbols which are generated by a source, they are mutually independent, their probabilities are not dependent on the probability of any other symbol. So that kind of source is called zero memory source, or it is also called as memory less source. Okay, and if we have taken an example, a source which is denoted by S, that is the memory less source, which is generating two different symbols. One is S1, another is S2. So S1 represents bit 1, S2 represents bit 0. And if the probability of transmission of bit 1 is P1 and probability of transmission is of bit 0 is P2, such that the sum of two probabilities will become 1. Okay, then we obtain the second extension of this source. So in the second extension, we will take the combination of all the symbols. So one possible combination will be 0, 0. So when we talk about second extension, so second extension means the number of symbol to the power the number of extension. So number of symbols are 2 here, to the power the number of extension 2, that is equal to 4. So we have 4 different symbols. So one is 0, 0, 0, 1, 1, 0, and 1, 1. So we know that each 0 is having probability, that is P2, and 1 is having probability P1. So since it has probability P2, so both are independent with each other. So the mutual probability will be P2 into P2, that is P2 square. Similarly, we also have noted the probability of other symbols. With that, we also have evaluated the average information of such kind of source, which is generating the second extension. That means 4 different symbols. So we have denoted like this. And from this, using their respective probabilities, we have got this equation. And this one we have written 1 divided by P2 square, that we have written 1 by P2 whole square, and this square will come to this side. The same thing has happened. And the second and third term, they are equal. So the summation will be 2 into this thing. So that we have done twice of this thing. And this particular thing, if you notice here, 1 divided by P1 into P2, that we can write 1 by P1 multiplied by 1 by P2. So it is in the form of log A into B. So log A into B can be written as log A plus log B. So we have written this as in terms of log A plus log B. So now if you see in this equation, we will take common from this term, and this term we are taking common 2P2 log base to 1 by P2. So this thing we have taken common. So here it will be P2, and from here you will have P1. So you will have P2 plus P1. The same thing by taking common from this term and this term, you will have this equation. So now if you see these two terms here, we can take common as P1 plus P2, because P1 plus P2 is here in the second term. P1 plus P2 is also here in the first term. So on taking common as P1 plus P2, we will have this equation. But we know in the very beginning that we have mentioned P probabilities of two symbols, that is equal to 1. So using that value of probability, P1 plus P2 equal to 1, So we can rewrite this. This is h square because it is the second extension. Since it is second extension, so the entropy or the average information we are writing in this particular form. And if it will be third extension, then we have to write f s of q. If we are find third extension. So see, since this became 1, so we will have this particular equation, which I have written by taking 2 as common, this one. So now this equation I can write in this form. Here you have p1 into log base to 1 by p1 plus p2 into log base to 1 by p2. So this I can write summation of I is equal to 1 to 2 pi log base to 1 by pi. So this thing is nothing but the expression of average information. Correct? So this I have written by h of s. So it will be multiplied by 2. So what we obtain, the second extension of that source is nothing but the twice of the average information of the first extension. So first extension means when you have only two symbols, one is S1, another is S2. If you want to find the third extension of such symbol, then it will have 3 multiplied by the first extension, the entropy of the first extension. All right. So if it will be asked to find the third extension, okay. So if it will be asked to find the third extension, so here you have two symbol S1 and into S2. So 2 to the power 3, that will become 8. So you have total number 8 number of symbols in case of third extension. So what are those 8 number of symbols? What are those 8 number of symbols? Those 8 number of symbols can be like this. We have no such thing. Okay, we can write here like this, because that will have 0, 0, 0, 0, 0, 1 up to dot 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 1, 1, 1. So this will be the third extension. Okay, so you will have total 8 number of symbols. And what is the respective probability? So it will have P2 Q. This will have 0, 0 is P2 into P2 square. 1 is P1. So P2 square into P1. And similarly, the final one will be P1 Q. So once you add up all those probabilities, you will get P1 plus PQ. Sorry, P1 plus P2 whole cube. So we know that P1 plus P2 is equal to 1. So this will become 1. So cube of 1 is equal to 1. So this also tells the sum of all probabilities you will get is equal to 1 also. Similarly, you also can verify in the second extension, as you are seeing here. If you add up all probabilities over here, so it will be P2 square plus P1 P2 plus this one is also again P1 plus P2, the P1 into P2, and the final one P1 square. So this equals P1 square plus P2 square plus 2 P1 into P2. So all of you know what this is. So it is nothing but can be written in this form P1 plus P2 whole square. And since we know P1 plus P2 is equal to 1, so 1 square of 1 will become 1. So that also verifies that the sum of all probabilities equals to 1. So whether we are doing the second extension or we are doing the third extension or nth extension, if you add all the probabilities, you will get the summation equals to 1. All right. So this is what we had discussed in the previous class. So in our today's lecture, we are going to take an example and let us see how we can solve this example. So this is the example which is given for us. Consider a discrete memoryless source. Okay, please underline it is a discrete memoryless source with source alphabets S is equal to S1, S2, and S3. So you have a source which is generating three symbols. One is S1, another is S2, and S3 with probabilities of 1 by 2, 1 by 4, and 1 by 4. S1 is transmitted at probability 1 by 2, S2 is transmitted at 1 by 4, and S3 is transmitted at 1 by 2. Find the entropy of this source. Also determine the entropy of its second extension and verify that it's of S squared. That means entropy of second extension is equal to twice multiplied of the entropy of first extension. So let us first address the first question, then we'll go to the second part. The first is to find the entropy of this source. So we know entropy of this source is nothing but I is equal to 1, 2, 3, because you have three symbols here, pi log base 2, 1 by pi. So that equals p1 log base 2, 1 by p1 plus p2 log base 2, 1 by p2 plus p3 log base 2, 1 by p3. All right. So since all values are given, p1 is given 1 by 2, p2 is given 1 by 4, and p3 is given 1 by 4. So you can write 1 by 2 log base 2. This is 1 divided by 1 by 2. I can write directly 2 plus 1 by 4 log base 2, 4 plus 1 by 4 log base 2, 4. You see this value and this value both are same. So log base to 2, it is 1. So this is nothing but 1 divided by 2 plus. You see here, this term are same. So you can write 2 into 1 by 4 log base to 4. So 2 into 1 by 4 is what? 1 by 2 log base to 4. I can write 2 to the power 2. So that is 1 by 2. So this 2 will be here multiplied. So 2 by 2 will be 1 log base to 2, it will be 1. So 1 by 2 plus 1, so it will become 1.5. This many bits per symbol. All right. So this is the answer to the first part of your question. Now second part, it is given also determine the entropy of its second extension. So what is the second extension? You have three symbols, S1, S2, S3. So second extension means number of symbols, three symbols. Second extension means 2 to the power 2. So 3 to the power 2 will be 9. So you have 9 number of symbols. All right. So how those 9 number of symbols we can arrange? This we can arrange like this. So one is S1, 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 S2, S1, S3, then S2, S1, S2, 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 S3, then S3, S1, S3, S2, and S3, S3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 number of symbols we have got. Okay, so what is the probability of S1, S1? We know that S1 is having probability 1 by 2, S2 is 1 by 4, S3 is 1 by 4. So here the probability 1 by 2 into 1 by 2, it will be 1 by 4. That is the probability. Okay, so this will have 1 by 2 into 1 by 4, it is 1 by 8. 1 by 2 into 1 by 4, it will be again 1 by 8. This is 1 by 4 into 1 by 2, 1 by 8. This is 1 by 4 into 1 by 4, it will be 1 by 16. This will be 1 by 4 into 1 by 4, 1 by 16. This will be 1 by 4 into 1 by 2, so 1 by 8. This will be 1 by 4, 1 by 4, 1 by 16. This will be 1 by 4, 1 by 4, 1 by 16. Now to verify this, if you add all probabilities, you will get 1. Okay, so you should check it. 1 by 16 plus 1 by 16. How much? 1 by 8. This 1 by 16 plus 1 by 16. This will be 1 by 8. So here you got 1 by 8. Here you got 1 by 8. So this 1 by 8, this 1 by 8 will be 1 by 4. This 1 by 8, this 1 by 8 will be 1 by 4. This 1 by 8, this 1 by 8 will be 1 by 4. So here 1 by 4, here 1 by 4, here 1 by 4, and here 1 by 4. So 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4, you will get 1. Understood? Okay. So what we are going to do here, we have to determine the entropy of its second extension and verify that HSS square is equal to 2 into HS. Okay, so we have noted down the probability. Now let us find out what is H of S square. Okay, any question? I think no. So that equals the summation of PI. I is equal to 1 up to what it will go? 9, because there are 9 number of symbols. Log base 2, 1 divided by PI. So this I'm writing it directly 1 by 4 log base 2 4 plus this one, what I will write 1 by 8 log base 2 8. Then this one same I will write 1 by 8 log base 2 8 plus this one again 1 by 8. So 1 by 8 log base 2 8 plus this one 1 by 16 log base 2 16 plus this one 1 by 16 log base 2 16 plus this one 1 by 8 log base 2 8 plus this one 1 by 16 log base 2 16, and final one is also 1 by 16. All right, so you see this 4 you can write 2 to the power 2, this 8 you can write 2 to the power 3, and the 16 you can write 2 to the power 4. Okay, so if you write 2 to the power 2 here, this power 2 will be multiplied here, So it will be 2 by 4. So 2 by 4 is equal to 1 by 2. And log base to 2 will be 1. So here 1 by 2 will come. And here it is 2 to the power 3. 3 will be multiplied here. It will be 3 by 8. Again 3 by 8. And this one 2 to the power 3. Again it will be 3 by 8. Here it is 2 to the power 4. So 4 will come. 4 by 16 is what? 1 by 4. Next one is also 1 by 4. Next one is 3 by 8. Next one is 1 by 4. And next one is 1 by. So if you add up all these values, what you will get, yeah, you see here 3 by 8, 3 by 8, 3 by 8, 3 by 8. So how many 3 by 8s are present? 1, 2, 3, 4. So that means 4 into 3 by 8. 4 into 3 by 8 will be 3 by 2. So 1 by 2 plus 3 by 2. Okay, plus you have 1 by 4, 1 by 4, 1 by 4, 1 by 4. How many 1 by 4s you have? 4 1 by 4s. So that means 4 into 1 by 4, you will have 1. So what this summation you will get? So 1 by 2 plus 3 by 2, it will be 2 plus 1, it will be 3. So 3 bits or symbol. So what we got, the value of s square, h s square is equal to 3 bits per symbol. And earlier we had obtained the first extension, that is the value of h of s over here 1.5 bits per symbol. So that we got 1.5 bits per symbol. All right. So if you compare these two entropies, so one is the second extension of entropy, another is the original entropy. The relationship is h of s square is equal to 2 into h of s. So this can be verified because 2 into 1.5 is 3. So this is what we can verify. Hope it is clear to all. Now let us move to the next question or next example. So this is okay. So this is the example now. Question given: an analog signal is band limited to 500 Hz. Band limited means it is given the maximum frequency max is equal to 500 Hz. And it's sampled at Nyquist rate. So if the signal will be sampled at Nyquist rate, so the sampling frequency is equal to the minimum sampling frequency is equal to 2 into the maximum frequency. So 2 into f max, that is 1000 Hz. The unit is number of samples per second. Okay, and the samples are quantized into 4 levels. Okay, how many levels we have? We have 4 levels of quantization. Please note it. We have 4 levels of quantization. The quantization levels are assumed to be independent, occur with probability given P1, P4 1 by 8, P2, P3 3 by 8. So what is the value of P1? P1 is equal to 1 by 8, P2 is equal to 3 by 8, P3 is equal to 3 by 8, and P4 is equal to given 1 by 8. Okay, so try to understand the question. An analog signal is given. I'm drawing the pictorial representation. See, this is an analog signal is given, and we are sampling the analog signal at a Nyquist rate. So sampling frequency is twice of the maximum frequency. So we are sampling at 1000 samples. It's not hours. Okay, so 1000 samples per second. Okay, so what is the representation of those samples? We can represent the samples like this, that you have studied in the previous semester. So these are the samples. So what is the sampling rate? It is given 1000 samples per second. That means per second 1000 number of samples are transmitted. And we have 4 different levels. 4 different levels means if we divide it into peak to peak, if we make the division peak to peak, so we have 4 levels: level 1, level 2, level 3, level 4. So try to understand the question carefully. The probabilities of levels are given. That means P1 is equal to 1 by 8, P2 is equal to 3 by 8, P3 is equal to 3 by 8, and P4 is equal to 3 by 8. So what does mean by that? When we are sampling, okay, so when we are sampling, suppose per second, how many samples? Per second, 1000 samples. So per second, we are transmitting 1000 samples. Understood? So probability is 1 by 8. Probability is 1 by 8. That means the samples which are lying in this particular label, that is P1. So they are how many samples? 1 by 8. That means 1 by 8th of 1000, because total number of samples per second is 1000. Okay, so its probability, P1 probability is 1 by 8. That means out of total number of samples, 1/8 part is transmitted per second at a probability of P1. Okay, so the samples which are present in the second level, they are transmitted at a probability of 3.8. Okay, that means out of 1000 samples, this many number of samples are transmitted per second, and those are the samples which are present in level 2. Okay, so that is the understanding of this question. So what we have to find out? Find out the information rate of the source. So information rate, we have to find out this one. That is the average information rate. So that is equal to RS into entropy. Okay, so what is RS? RS is the sample rate. At what rate the samples are transmitted multiplied by the average rate of information or average information. Okay, so RS value is given because we are transmitting 1000 samples per second. So RS is given. We have to only find out the average information. The average information, we can use the formula, that is I is equal to 1. What is the maximum limit? It will go up to 4 because we have 4 different samples or 4 different levels. 4 different levels means 4 different kind of samples. Whatever the sample present in level 1, they will be considered as one type of sample. Whatever samples are present in level number 2, they will be considered as one type of sample. Whatever samples are present in level 3, they will be considered one type. Whatever samples are present in level 4, they will be considered one type. So we have here 4 types of samples. So this one you should write in this particular form. On expanding, you can write also like P1 log base 2 1 by P1 plus P2 log base 2 1 by P2 plus P3 and P4, like this you can write. So P1, P2, all values are given. So using their respective probability, you can find out the average information. RS value is given 1000 samples per second. So whatever value you are getting, the value of average information, you multiply with 1000. So you will get the final result, which I have calculated as 1811.3 is many bits per second. So this is the approach how to address any problem or any example which will be asked in the exam of such kind. Now, let us move to the next topic. So the next topic is the dependent sequence. Long dependent sequence. So what we have earlier we were doing, we are taking a sequence. Every time we are taking a source, and source is having some set of symbols, and each symbol we have considered as independent with each other, and we denoted that as the memoryless or zero memory system. Now in the next topic, we will come across one more topic that is called long dependent sequence. So dependent sequence means in this case, all the symbols, they are dependent with the previous symbols. So they are not independent. Okay, so if some sequences or some kind of source is there, so what will be the average information for such kind of sources, that we are going to see in this particular topic. So if you take any practical examples or real world examples, all the sources, they are dependent sources. They are not independent sources. So what I mean to say, all real life examples, what we are seeing, all are dependent. It's not independent. So suppose a source which is emitting a sequence of symbols, and any symbol in that sequence is dependent on the previous q number of symbols. Try to understand carefully what I am saying. If a source is emitting some set of symbols, and among all the set of symbols, any particular symbol is dependent on the previous q number of symbols, then that kind of source is called qth order symbol is called qth order Markov source. Or that is also called as Markov qth order Markov source. So how we can define a Markov source, or how we can define a Markov source is defined as if any symbol in a particular source is dependent on the previous symbols, that kind of source is called Markov source. So all Markov sources are the dependent sequences. Okay, so if any symbol in a source is dependent on the q or dependent on the q number of previous symbols, that kind of source is called qth order Markov source or qth order Markov source. Okay, so in that case, what should be the entropy? So what should be the entropy of such kind of source, which are where the symbols are dependent? So we will see what is the entropy for that, or we'll see the average information for such kind of source. So let us consider a parameter which is denoted by hi, and here I will represent hi is equal to summation of j is equal to 1 to n p I j log base 2 1 divided by p I j. Okay, so here let me explain each parameter in this particular expression. Here hi represents the entropy of ith state. Okay, because in this case the source is having many states. So ith state is having entropy hi, and in that case you see one counter is given j is equal to 1 to n. So what is n? What is small n? Small n represents, this is the small n represents the number of states on which the state I depends on. So what is n? N represents the number of states on which the present state I depends on. Okay, so in this case there are n number of states on which the current state I is dependent. So what we are calculating, we are not calculating the entropy of the source, we are calculating the entropy of state. Keep it in mind, very carefully understand. We are not calculating the source entropy. We will calculate the individual entropy of each state. And finally, we will calculate what is the entropy of the source. So when in case of Markov process, each state is dependent on the previous some number of states. So we shall first calculate what is the average information of that particular state, whereas that state is dependent on the other source states. So we have to calculate the individual entropy of every state. So once we can calculate the individual entropy, so the final entropy is equal to the summation of I is equal to 1 to n pi into hi. So hi we have calculated over here. So hi is nothing but it is the entropy of every individual state. And what is pi? Pi is what? Pi represents the probability of each state. So it is called the state probability. This is called the state probability. Okay, understood? So this particular equation represents the average information of the source, whereas this particular equation represents the average information of each state. Now, if we sum all the average information of every state, so that will give us the final information or final average information of the source. Correct. So we can take an example. Suppose I have a source. This is A, this is B, this is C. So this is one state, this is another state, this is another state. So this state is dependent on this, and this state is also dependent on this. So this state dependent on this is also dependent on this. This one also dependent on this is also dependent. So like this, they are dependent on each other. So what we will calculate, we have three different states. This is state A, this is state B, this is state C. Okay, so here in this case, when we are calculating the probabilities, so we will calculate the average information, that what is the probability the state I is dependent on state J. That means state A is dependent on state B, state A is dependent on state C, so on like that. We will see it by an example in the next class. Okay, and once we can find the average information of the source, we can also write the information rate, that is equal to, that is equal to the symbol rate multiplied by the average information. Okay, so this is the information rate of any Markov process. All right, so any question at this point? No. So let us come to one theorem of Markov process. So the theorem tells the value, one parameter Gn, this equals to 1 divided by n summation of I probability of mi into log base 2 1 divided by probability of mi. So this equals 1 divided by n into average information to the power n. So what this Gn represents and what the n represents? N represents the number of state. We have how many number of state we have. That is the value of n. So we will, and as the value of n increases, the value of Gn will gradually decrease. So that we will verify in the next lecture when we'll take an example based on the Markov process. So we have three different examples for Markov process. So we will try to solve those examples in the coming classes. I hope tomorrow we will see it. Okay, if you have any question, you can ask